Okay, number 6 is going to be complete the following reaction. And this reminds me that I'll probably need to put a periodic table along with this test, huh? Because what we're going to have to do is complete the following, complete.
This?
Gesundheit. Okay, A. These are all nuclear processes. I'm taking nitrogen 14. I'm bombarding it with a neutron. And one of the products I get is carbon plus. And now, how do I complete this? What has to be true here? What goes in top? I've got.
You got a balance.
I have, what's the top going to be?
15.
15. And what goes on the bottom?
Or do you?
7 on the bottom. 6. So this is 6. So what's this
1.
got to be?
1.
1.
Oh, I see.
1. That's why you have to have a 1 on the top.
Okay.
Yeah.
Yeah, because 14 plus 14.
Oh, 14 plus 14. Oh, no. 14 plus 1 on top. Excuse me.
No problem.
My bad. Thank you, Robert. I was about to realize that there is no such particle with 15 on top. But that was a minor difficulty. Okay. Now, what type of particle is this? That's a proton. No, proton. It has a charge number of 1 and a mass number of 1.
And a positron is something that has just a charge number and no mass number?
No mass number, yes.
But a positive charge?
Positive charge
Yeah,
number,
right.
yes. It would be like an electron or a beta particle. Okay. So this would kick off a proton. So B, let's see if I can do this one without screwing it up. Okay. U-235. So uranium plus a neutron. I bombard it, and I'm going to get, it's going to fizz apart. One of the fission products is cesium-55 plus, and now I've got to go, this is 236, so 236 minus 144. Is it 92?
Yes.
Okay, yeah. Okay, yeah, I agree. So it's going to be 92 on the top, and now 92 and 55.
37.
Oh, thank you. 37. Now we've got to look at the periodic table for what is atomic number 37.
Rubidium.
What is it?
Rubidium.
Rubidium? Is it? Okay.
Mm-hmm.
So that's why I'm going to have to give you guys a periodic table, okay, for you to solve that.
So even though the mass number doesn't line up
What?
with rubidium, even though it's 92?
Oh, it doesn't matter. It's the
Okay.
atomic number.
Okay.
That was what makes it an element. It's an isotope of rubidium.
Yeah, I get that.
Didn't say it was a popular isotope, but it's just an isotope. Yes?
So for part A, if we're looking, I just thought it was just going to be elements. So it wouldn't be hydrogen just because of the 1?
Oh, I could, well, that's what a proton is. You could put this, and I'd be perfectly acceptable.
Oh, okay.
That's what a proton is. What do you think a naked hydrogen atom is?
Cold.
Cold, exactly. Embarrassed, perhaps.
So it could be hydrogen.
Yeah, it's the same thing. That's what it is. A proton, the nucleus of a hydrogen nucleus, which is just a naked proton. So it's a naked hydrogen. Okay, what's the next one? Tritium.
Right, that's the like.
The bottom
Now, this particular process is part of the fusion is a possible fusion sequence where I'm taking two little bitty nuclei, a tritium and a deuterium, and I'm slamming them together, and I get a helium plus, now 3 and 2 is 5, 5 minus 4 is 1, and 1 is 2, and 2 plus what is 0, and so what is that? Is that the thing we were talking about earlier?
The positron?
Beta.
A positron or a beta, yeah, a positron. I can denote it that way. You could go 1, 0, E would be the same as a positron or a beta particle, because beta radiation is just electrons.
Can you write positron? No.
You could if you want. I would accept it.
Really?
Yeah.
So the answer key is incorrect by saying 1, 0,
One, what,
N. In the
what?
answer key,
It is? What's it say?
1, 0, N.
Oh, wait a minute. No, it's not, because a neutron has mass.
Well, what's the N in the 14-7 nitrogen?
Oh,
Because it's going backwards from the first one.
oh yeah. Oh no, you're right. It could be one. Oh, this is a neutron. Jesus.
Because it has a mass of 1 in it.
Yeah, I'm bad. I'm really bad.
I knew it.
That's one and no charge.
You said neutron. No charge.
But if it was the other way, then it
No
would be
charge.
positive.
I don't know how I missed that. I was looking at the mass number. Okay. So I'm obviously very dingy. Pay no attention to what I say. This is the right answer.
Drink more coffee.
I better drink some more iced coffee and then do the last one.
You want a slice? No.
Pay no attention to that monitor.
Yeah, pay no attention to whatever I say. Under any conditions. Okay. D is, I'm taking 8,4 beryllium, and this is another part of the nucleosynthesis that is occurring in the sun. Where this combines with a helium nucleus. And this is where one of those elements that we really know and love and we wouldn't be here without is formed in this very type of process. Let's look at what's on the bottom. What element do you think it's going to be? 4 and 2 is 6. So what is it? It's carbon. Now 8 and 4 is 12. It's carbon 12. That is, so the last two are fusion type processes that occur in the, are proposed to be occurring in the sun. And this is how we get helium. We start to burn tritium and deuterium to helium. And then when we get to beryllium-8, which actually forms just for a very, very short time, but it's long enough in existence to where it can combine with a helium to give us carbon. And that's part of the nucleosynthesis. Okay, that is about all we're going to deal with as far as nuclear. We may have another question or two in the multiple choice about that. Okay, is that good? With all my faux pas.